This microscopic roundworm is chasing food. Food that doesn't exist. Scientists have tricked the worm, and they did it by taking over control of its tiny brain. Sharad Ramanathan and his team want to better understand how biological networks operate. They've spent the past 4 years studying the 300 neurons that make up the worm's brain and finding ways to track and control each one. They genetically engineered the worm's neurons to emit fluorescent light so they can track them, and to become light sensitive, so they can turn each one on or off with laser pulses.
And suddenly by controlling that neuron, we could control turning left or right, going forward or backward. And this neuron receives lots of sensory information. So just by controlling this neuron, we could figure out how the animal should move and remote control it, basically. And then the point was, can we make it think there is food? And just by controlling the activity of this neuron, we could make it think there is food, make a beeline for where the food was supposed to be, except that there was no food. It was just we're playing with the brain to make it think that there is food.
Researcher Ashkan Kokaba says the hard part was developing the system to track and target individual neurons in the worm's brain while it was in motion.
We are using complex image processing algorithms here, and then we can acquire the image, we can process the image, and we can identify the neuron positions, and then we can specifically focus the light into specific neuron.
And even with the tiny worm squirming away, they managed to accurately fire lasers at its neurons 50 times per second. The system uses a movable table which keeps the worm centered beneath an ultra-fast camera. Once they have the real-time image, they can target and shoot neurons, giving them overall control of the worm's brain.
The question further up is to say, can we also start doing such things with higher organisms like zebrafish, where the brain is infinitely more complex, or so it seems, and start asking similar questions in the hope of understanding how biological networks are designed.
Zebrafish brains are a lot more complex than the roundworms. Ramanathan says developing a system to control them is still years away. He says tracking and targeting a microscopic worm is one thing, but keeping up with a moving fish is still the stuff of science fiction.